Hi, I'm Rich with Inside HPC. We're here in Frankfurt, Germany at ISC 2018, and today we're at the Lenovo booth with Rick Koopman. Rick, thanks for having me back. Well, let's start at the beginning for folks that might not know. Who is Lenovo and who do you help in this supercomputing space?
Okay, so, to remind people, Lenovo is one of the biggest IT organizations based out of initially a workstation PC, a ThinkPad organization,
Yes.
which was expanded by the server group of IBM in 2015. It's one of the bigger IT organizations in the world, and what we're doing with our capabilities and technology is, trying to really address critical issues in the field. No matter what it is, if it's life science related, industrial related, if it's governmental related, we're trying to fix complex issues with the deployment of our capabilities, certainly in the area of our HPC capabilities.
Okay. And what are you showcasing this week at ISC?
So what we're showcasing is not only our hardware portfolio, but also a couple of demos that we're running that we've built with a number of business partners and through collaborations with a number of customers that we have been working with closely. That's typically also our approach, to collaborate with a customer, so not only be a hardware provider and install the hardware, but work closely with them to help them optimize their applications, help them fix issues with their applications, with scalability or with data center, to make sure that everything they're doing is as efficient and optimized as possible.
Well, last year we were talking, you had just launched the Think systems. You have these here, don't you?
Yes, we have the entire portfolio of Think systems over here, from Blade Center up to 1U servers, 2U servers. We have the storage arrays over here. We have the DS6200 storage enclosures over here, which is an IOPS intensive storage solution. And we have our new network capabilities over here. The entire portfolio complemented by specific HPC and AI, specialized hardware building blocks with multiple GPUs, and the solution that we are deploying at this moment with LRZ in a form of direct water cooling capabilities.
Do you have that water cooling technology here? Could we take a look?
We have the water cooling technology over here, and we definitely can show you and take you through it.
All right, Rick, what do we have here? It looks like a lot of liquid cooling, a lot of density.
It is a lot of plumbing and piping, what you see in here. So basically what you see over here is one tray containing two nodes. So this is the solution that we at the moment are deploying at LRZ near Munich. And it is based on the newest technology on water cooling. So what we have done, it's the fourth generation of the water cooling technology that we have deployed at customer sites already. So we've further optimized what's happening inside to increase the efficiency. So the efficiency is now over 92%. So heat transfer to water. We can achieve that by not only cooling the processors, but also cooling the memory DIMMs. We're cooling the drives, and we're cooling the network connectivity that's in here. So what we're doing with one node is we have a loop coming in, the loop splits to the second node, and within this, the loop also splits into a CPU loop and a memory and peripheral loop. So to make sure that we have a very predictable water flow and that we have predictable outcome of the water temperature and the increase of the water temperature.
Well, what does that do for the customer that you're able to pull this off?
Well, what it does for the customer is one of the biggest cost centers in a data center are chillers. So through something like this, you can reduce the level of chillers to only have to support your network topology and your storage environment. The rest, all the computational power, will be cooled by water of 50 degrees Celsius. So it sounds ridiculous, but it isn't. As long as it's cooler than 75 to 80 degrees, it cools. So the water goes in with 50 degrees Celsius, comes out at a little bit over 60 degrees, can go two ways. So it can go to a free-to-air unit at the roof, come back at 50 degrees Celsius. It can also be, and that's what we're doing now at LRZ, be used in a dispersion chiller. So what that does, basically, it means it creates from warm water, chilled water with an efficiency of over 50%. So they don't need chillers anymore for the racks with the network components and the storage in there. So, it is a chiller-free environment.
Okay. And is this part of the project Neptune that you guys announced recently?
This is part of the project Neptune. We have three areas that construct Neptune. One of them is direct water cooling, so water cooling to the CPUs and to the memory DIMMs and the rest. So again, the memory DIMMs, it's not a hot plate technology. It's real tubes that have flowing warm water going through it, chilling the memory DIMMs. So this is one area that part of Neptune. The other area that is part of Neptune is the radiator heat exchangers. Radiator heat exchangers that optimize the way the data center operates and the temperature in the data center through the air that's blown through the rear of the rack. And the third topic of Project Neptune is to complement everything we're doing with this and the radiator heat exchangers with energy-aware runtime. So energy-aware runtime is going to be operational at LSE also with over 6,000 nodes. What it basically does is it is determined based on the MPI traffic within job, what the behavior of the job is. So it doesn't operate at scheduling time, it operates at runtime. And based on the profile that it defines of the job, it automatically throttles down the frequency of the processor if the job is an IO bound or a memory bound job, which reduces the energy consumption of a data center tremendously.
You guys are building these big systems with a very, what I would call a fat, no, it was like a 6U. Is this it here?
This is a 6U chassis, and that is something that we've decided on with the introduction of the next skill, which is about 6 years ago now already.
Right,
So from a density perspective, it is a very nice structure, 6U, because 6 of these enclosures give you a full rack, give you 72 nodes. Add the network connectivity that you need, and you have a completely filled 42U rack with all the network peripherals that you're going to need into it. But what it also brings you is that you can optimize the number of power supplies that you have in your chassis. So if you would be having a 2U 4-node construct, you will be struggling with splitting and balancing the power over your power supplies and within your chassis. So now you have the opportunity to have enough power supplies in there to always have full power of your chassis and your compute nodes in your chassis, even when one of the power supplies fails. So that's important, and it reduces the level of plumbing and piping. You only have one connection to 12 nodes basically. So you can imagine what happens if you do this and you have 2U 4-node constructs. You have a lot of these connections in there at the back of your rack, and we can do now with 6 water drops. That's how we call them. It's an installation at the back of the rack. We simply connect the chassis to those drops, and we have them in an order of 6, 5, whatever you want. But 6 is typically the optimum. Most implementations use 6 or 5, depending on the power connectivity value the customer can support within one rack. Because there's still a couple of older data centers that cannot support up to 30 or 40 kilowatts a rack.
Right.
So if you have a full rack, it's up to 40 kilowatts at the moment. Processors are 240 watt at the moment.
Serious, yeah. Well, Rick, I can't let you go without congratulating you. For Lenovo is the #1 vendor on the top 500. The list came out this week.
Yep.
You're doing a lot of innovative stuff to get there. I know that's some of the toughest stuff and problems to solve, and you're helping the customers do that.
We're very proud
congratulations.
Of that. Thanks very much, man. We're very proud of that. It has been, since we transferred from IBM to Lenovo, we spent a lot of time in improving what we had, improving what we do, improving the way we do it. And this basically proves that we have done it the right way. And now let's go up to #1 also in the future, is it? To have the biggest one.
Yeah, there you go. All right, well, thanks for sharing that with us today.
You're welcome, Rich.
Good job.
Thank you.